Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 2nd, 2025. So that was just 5 days ago. This paper finds that even top multimodal foundation models like GPT-4o are not close to state-of-the-art specialist models, lagging by over 30 points in some object detection tests. The paper is titled, How Well Does GPT-4o Understand Vision? Evaluating multimodal foundation models on standard computer vision tasks. And as we'll see, the way they managed to benchmark these models is pretty clever. The authors created a framework using prompt chaining to evaluate these API-only models on classic vision tasks. Also, the authors shared their official implementation on GitHub. You'll find their complete prompt chaining framework there. It includes all the scripts, notebooks, and clear instructions to get started. It's everything you need to actually run these benchmarks on different multimodal models and see the results for yourself. Alright, so this first figure really visualizes the core findings. The bottom half shows an example. Given an image of a zebra, the model is asked to perform several classic computer vision tasks, like classification, object detection, and segmentation. Now, the radar chart at the top plots the performance of models like GPT-4o and Gemini. And that outer dotted line represents the state-of-the-art. The performance gap is immediately obvious. These multimodal models are respectable generalists, but the chart shows they lag significantly behind the specialist models on every single task. Building on that idea of prompt chaining, this next figure shows exactly how they do it for object detection. It's a really neat recursive process. First, they take the input image, say of this sheep, and divide it into a 3x3 grid. Then, they use a multimodal foundation model, or MFM, which is a model that understands both images and text to identify which grid cell contains the sheep. That cell then becomes the new image, which is divided into a grid again, and this process repeats, zooming in until they get a precise bounding box. So, this next figure gives us a great visual comparison of how different models handle these tasks. You can see the input image, the perfect ground truth result, and then a column for each model like GPT-4o and Gemini. The rows show different challenges, from semantic tasks like object detection, which is about identifying what is in an image, to geometric tasks like depth prediction, which is about the 3D layout. You can clearly see the models perform better on the semantic tasks. Their object detection is pretty good, but their depth maps are very coarse and blocky compared to the ground truth. Moving to the results, this table details the performance on image classification. The numbers show the top 1 accuracy, which is simply the percentage of time the model's single best guess for an image label is correct. The columns test the models on different benchmarks, including corrupted images and sketches, which checks for robustness against domain shift. That's when the test data looks different from the training data. You can see the specialist models are still on top, but GPT-4o is clearly the best of the multimodal models, showing it's a strong generalist. This next table then details the results for object detection. The main metric here is average precision, or AP, which is a score that combines how accurately the model draws a box around an object with how well it identifies what's inside that box. Once again, we see a big performance gap. The specialist model, County ETR, scores a 91.3 on the AP50 metric, while the best multimodal foundation model, GPT-4o, gets a 60.6. This really reinforces that theme. These generalist models are respectable, but still have a long way to go. Okay, now let's look at semantic segmentation. This is a more detailed task, where the model has to label every single pixel in an image with a category, like sheep or grass. The main score here is mean intersection over union, or MIOU, which measures how well the model's predicted shape for an object overlaps with the true one. And the story is very similar. The specialist model, OneFormer, scores a 65.5 on MIOU, while GPT-4o, the best of the multimodal models, is at 44.9. So again, a respectable performance, but a significant gap remains. So to wrap things up, the big takeaway here is clear. While multimodal foundation models like GPT-4o are impressive generalists, they still can't match the state-of-the-art specialist models in any single task. We saw that they perform much better on semantic tasks, identifying what things are, compared to geometric tasks, which involve understanding 3D space. This work provides a great benchmark, showing there's still plenty of room for these models to grow. That's all for this week's AI Research Roundup. Thanks for tuning in.